Hello, welcome back to BLENDERSUSHI live noding. In this video, we're gonna explore a little bit of particles using animation nodes. Basically, this is just like an experimental. We'll see how far we can go. So this is what I have at the moment, is a particle being emitted. Each one of them is separated by around 4 or 80 frames difference. If I go to full screen, you can see it's in real time, a little bit faster. So there's like a bunch of particle emitter, and each one is emitting particles. It's actually like a multiple particle systems. Normally, it's kind of a hassle having to set this up. One particle system is usually what you're dealing with, but I guess with animation nodes or maybe SphereChalk, you can control like many of this kind of system. Yeah, let's see how it goes. At the moment, it's just really just kind of like the same particle system. I need to randomize the seed as well, I guess, in order to get a different result. But yeah, let's have a look. This is gonna be like pretty basic, I guess. But I've never done this, so let's see. This should be like the beginning of particle exploration using animation nodes. So this is AN basic particle multi-particle system basically. Okay, let's start. Fireworks setup using animation nodes. So first of all, we need to know a little bit of the basic of particles. We want to emit it from something. If we just apply the particle system into this guy, the box, we have options. You want to emit it from vertices or faces or volume. Vertices, let's have a look. Okay, it's doing that. It's being pulled by the gravity. I can perhaps turn off the gravity for now. Turn off gravity. So now it's emitting through the normal. I can also turn off the normal and then let it being emitted randomly in all directions. But having too many points, even just a box, this is like 8 points or 8 vertices. It's a little bit of hassle, so I just simplify this into a single vertices. So I will go to edit mode, merge into center. So now we have only 1 point where the particle is going to be emitted from, and by default we have 1000 particles maximum, start at frame 1 and end at frame 200. Lifetime for each particle is 50. Let's even simplify this further, like let's say you want it to be emitted at frame 50, start and end at frame 50. That's kind of like a burst of particle at frame 50, just like that. That's kind of what I will use for now. Maybe even just 100 particles, just like that. Poof. And then 50 frames and it disappear. I'm not gonna care about the fade in, fade out at the moment. Yeah, we're just gonna duplicate this guy, the emitter. This is so emitter. I call it emitter, and then we're gonna switch to compositing animation nodes. Let's have a look. First of all, object instances for sure. Instancer, and grab our master. It's slowing down already because I'm recording and it's calculating every frame. Turn off and just have these 3. We're gonna copy full objects and do the deep copy. And let's make like 10 instances and get our master emitter. Now if I scrub, it will update it. Now we have like this is the emitter master, you can see down below. And then if I right click and then click, it's like we have 10 instances that we already copied. First of all, let's randomize the positions of our emitter. So let's do that using object transform output. And it's up to you how you want to randomize the position. You can use the random vector, plug in the index into the seed and the output into this guy, and then we can actually plug the object into that guy. Now we can randomize the position. Okay, we can see there's a dots there. It's too small. Maybe I should turn on the background color. Background color instead of gray, I'll have like greenish. Display world background. Turn off grid points. And turn off parenting. If you don't want to see the lines, you can turn off the parent relationship lines. Okay, so now if we scrub and then check, we can see the particles actually being emitted, but the color is weird, we cannot see it. Now I'll just use like a grayscale-ish value. So each particle seems to be doing the same thing. This guy is actually the same kind of setting, I think. Let's have a look. Yeah, even though we are using instancing and then it's doing this copy full objects and deep copy, the particle itself at the moment is still using the same data from the master particles. Let me open the outliner, and this is the master outliner. I'll just this is the master emitter. I'll just put it in the layer number 2 so we don't see it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 copies. Each one have let me select one of the copy. So each one have a particle system modifier applied to the object, so they're emitting, and the particle data is using the same data, because you can see here it's a 11. It's a 11. The particle setting is the same data block that we need to take care. So for now, I will actually gonna manually make it single user copy. Click on that thing. So one by one. I wish there's a faster way to do this. Supposedly, maybe make single user all. Yeah, maybe that does the job. Maybe make single user all. No, it's not doing it. That's one of the things. Let me check real quick. 10, 9, 8, 7, 6, 5, 4. So now its particle system data block is unique for each of this guy. I can actually we can randomize the seed, and each one of them should be different. But like I said, doing this manually is a kind of a hassle. You need to either use Python script, or you can use animation nodes for this, like what we're doing now. So there you go. Each one of them is bursting because we randomized the seed. For some of them it's a little bit random, I think. Let's see. Let's use animation nodes to randomize the start end. At the moment, it's all doing it at frame 50. Let's randomize that using animation node. So object attribute output, and so this object we need to get to this guy. We need a way to get to the data, to the parameter. Currently, if we see it's a bpy.data particles blah 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 frame end. With animation nodes, we can actually dig into the particles from the objects. The way I do it, I think I'm just gonna show you how I do it. I'm using particle Python console actually, and then I'm starting to start digging the objects. Let's say I know the object name is emitter.010, for example. That's one of our object instance. I'm gonna put this into a variable. Now I want to dig into the particles. Control space, and there should be like particle systems. Okay, particle system, and there's okay. The name of particle system is particle system 1 or particle system. It's called particle system. So we can of course have multiple particle systems, but that's what we have for now. And then we want to get to the settings actually, and the settings should have our frame end and frame start. We can change this over here like this, and you see it's updating already. Let's say we are putting like 33 and then frame and 33. Should be updating start end. That's what we're gonna use in here. So object particle system, just grab this guy, paste it here. Value has wrong type. That's a good sign actually. So that's the whole path to our attribute parameter there. Frame end and frame start. For now, we're just gonna make it the same. Okay, let's hide this. The value, let's say we're gonna randomize the value, random number between 20 and 40, for example. Plug that in there, plug that in there. Let's scrub. So now, yeah, so you can see it's now already being randomized. Let's say between 10 and 40. File save. And we want to also randomize the seed. The seed should be also under settings. So it's a seed. I believe the seed should be expecting like integer value. Oh, it says attribute not found. Interesting. Particle system seed. Apparently it's not under setting, it's under SEED. So yeah, let's use this guy and then randomize the seed. Actually, with the seed we can just plug in the index, and now each of the particles should be different. Let's quickly have a look in the 3D. Set this to 100 frames only. 3D view full playback. So we can see yeah, that's pretty random, and then each one of them is also different. Yep, that's that should be all right, except that currently the only downside is if we want to have like a 30 instance, for example, of course 30 instance gonna update itself, and we have like 30 of this guy, but you can see some clones actually is using the same block of data. You see now we have like a 30 emitter instance there, but here, this is the thing that's always annoys me a little bit. It doesn't make it a single unique data block. Maybe this, maybe we can use Python to do this. For now, I'm just doing it manually. Seven, 6, 5, 4, 3, 2, 1. Okay, now we have like a 30 unique particles being emitted randomly. So it's almost like fireworks. Okay. Yeah, I guess that's pretty cool for now. What else can we do? That's to randomize this guy. I have not looked into the coloring and instancing of particles. With particle material also, since we have like cycles render nowadays, coloring particles, it's something that you can do in the materials, I think. Let's see. Color can be based on the accelerations, velocity, material, non-material. So this is material. If I use red, so each particle is now red color. So it's looking at the same materials. I think again this one is using the same material, which we need to make a single user, I guess. Let me try. If we are doing it manually, so that's green, you can have like blue, this one's yellow. You are okay, make it single user, and then yeah, I guess that's how you can randomize the particles color by using the material. If we want to use animation nodes to randomize the color, let's have a look. So BPY context object active material diffuse color. Active material diffuse color. Again, I'm gonna use object attribute output, and this time we are using the objects, but what's the path into this guy? Right click, copy data path, paste it here. Diffuse color. Let's see if it's reading it. No, it doesn't like. We need to. Let me try Command Alt Control Alt Shift C and then paste it here. So BPY data material. The nice thing about animation nodes is we can access the material like this, I believe. So data.materials material.004 diffuse color. Key not found. Let me try to troubleshoot this. So again, I'll look at one object, DPY data objects, emitter.027, that's our object. And our object should have material slot, materials for. See, you can kind of control space to get to that guy. Material. String allowed as key. Is it a diffuse color? Okay, I think this is the path. Material slot. Material slot. I believe with the slot we can just use the index instead of the name. Now, okay, I think it's correct. Material diffuse color. Value has wrong type. Maybe we can use, hopefully we can use just RGB. Okay. If we use the combined color, this is gonna fail. No, it doesn't like it. So we need to separate color. Colors RGB, and we use a vector, combine vector to put the RGB back. RGB. Now, yeah, I think we are into something. Currently it's all black because of this RGB. Now it's all blue somehow. Hue saturation value. It should be RGB. GB. Yep, that's correct. Now, obviously at the moment it's using the same hue, that's why it's the same color for each one of them. Let's randomize the hue. Random number, index to the seed, min max 01, plugged into hue. Okay, we have random color, but not for this guy. You know why? Because of the material. Okay, I need to make it like unique. I'll do it manually for now once again. So I'm looking into this guy one by one. Okay, that should be unique. You should be unique. If you know any way to make this guy unique using Python or other method, just please let me know in the comments. Yeah, for now just gonna do this for a few seconds. I guess under 100 this is still kind of okay. If you have like 1000 particle system, then it's it's gonna take 1000 seconds to do this, or you just use Python. Okay, now if I update, we're gonna have different color for each particle. Yeah, kind of like that look. Alt A, and then we have, there you go, there's particles. Maybe we can use the gravity, get the gravity back. Currently, even though they're random color, each one of them has different seeds, so they all look different. They're still kind of the same because they all kind of, the lifetime, we haven't randomized the lifetime for each particle, and I don't use any turbulence or anything. If I use like if maybe force field turbulence. That's gonna give a little bit something. So it's our turbulence. I think turbulence is good. It's always good. Give us strong turbulence, like a 10. Now it's no longer like a fireworks. It's like fireworks in the really windy day. Let me make this dark background. Turn off relationship lines. Yeah, turbulence is a little bit crazy at the moment. If I turn on the flow, even it's crazier because the particle is gonna start to float. Can be cool. Noise also global. Well, yeah, that's just I guess a quick introductions to how you can control and orchestrate multiple particle system. We have like 30 of them. Not too many yet because we need to make each of these unique one by ones manually. If you know the Python code to do that, please let me know. Yeah, so there's a lot to randomize and to make a variations for particles. Like each particle also has its own position and what else, like a lifetime and size, weight, so many things like velocity that we might touch at some point. But for now, I guess this is alright for a starter. Particle color and particle emitter positions we have randomized. We can control, and then also when we control it when to burst, we can easily randomize it. So that's the cool thing about it. Yeah, I guess that's all for this live noding. Hopefully you find this useful. Let me know if you have any question down below. I'll see you in the